Good morning students, this is Latif sir. In this video, today I am going to start the chapter 4 of class 8 chemistry. The topic is atomic structure. Atomic structure, fourth chapter of class 8 chemistry. So first you have to know what is an atom. You have already studied that everything around us is a matter, and matter is composed of very small particles, and these particles are known as atoms. Okay, so atom, the smallest particle of matter, which is called atom in modern term, and it is also called parmanu. Okay, smallest particle of matter, that is parmanu or atom. And what John Dalton told about atoms in his atomic theory. So let's see Dalton's atomic theory. In Dalton atomic theory, he told that all matter is made up of very minute and electrically neutral particles, and these are known as atoms. According to Dalton, all matter is made up of very minute particles and electrically neutral particles, and these are called atoms. And atoms are indivisible. Atoms are indivisible and can neither be created nor destroyed. All the atoms of an element are identical in mass and properties, and the atoms of one element are different from the atoms of other element, and the atoms are smallest unit of matter and that take part in chemical reaction. Atoms are the smallest unit of matter that take part in chemical reaction, and atoms of an element combine with atoms of another element in a fixed ratio to form molecules of compound. Okay, atoms of an element combined with atoms of another element in a fixed ratio to form molecules of compounds. And the number and types of atoms in a given compound are always fixed. And when atoms combine, they do so in simple numerical ratio. For example, in water, the hydrogen to oxygen ratio is 2:1. Okay, so when atoms combine, they do so in simple numerical ratio. This point gave by John Dalton in his atomic theory. Okay, this point he told about atoms. Atoms is the smallest particle of matter. Atoms are indivisible, can neither be created nor be destroyed. All atoms are identical. All atoms of an element are identical in mass and properties. Okay, and atoms are the smallest unit of matter that take part in chemical reactions. So John Dalton told this point about atoms. Now see discharge tube. What is discharge tube? It is a glass made instrument. Okay, a discharge tube consists of a long glass tube closed at both the end, and it has two metal plate plate A and plate B, which are also known as electrode. Plate A act as cathode and plate B act as anode. Okay, and this is a closed tube, and the plate A is attached to the negative terminal of high voltage source and act as cathode. Plate B attached to the positive terminal of high voltage source and act as anode. And the pressure inside the tube is very low. Okay, this is discharge tube. In this discharge tube, if you pass electric current, then you will see an invisible ray which is originated from cathode and will travel towards anode, and this is known as cathode rays. Okay, when a high voltage about 10,000 voltage is applied across the plates, okay, across the plate A and B, along with a very low pressure, The portion of the tube behind the plate B glows with a greenish yellow light, and this glow is caused by invisible ray that emerge from the cathode under the given condition, and these rays are known as cathode rays, because cathode rays are originated from cathode and it migrate towards anode. When high voltage difference is applied between two electrode. This is a simple experiment. Using this cathode ray experiment, later scientist George Thompson discovered electron. Okay, so now see fundamental or subatomic particles of atom. That is, which particles are present in an atom. Okay, there are main three subatomic particles, which are proton, neutron, and electron. Okay, so these are three subatomic particles. So you have to read about discovery of proton, discovery of neutron, discovery of electron. Okay, details experiment is not required. You have to remember the name of the scientist and using which experiment they discovered these subatomic particles. So first discovery of electron is given. The name of the experiment is cathode ray discharge tube experiment. Okay. J.J. Thompson. The first subatomic particles electron was discovered by J.J. Thompson. Which scientist? J.J. Thompson first discovered electron in 1897 through the cathode ray discharge tube. Okay. Detailed experiment is not required. Remember the name of the scientist who discovered electron and using which experiment. The name of the experiment is cathode ray experiment. Okay, and J.J. Thompson found that when he passed the cathode rays between two oppositely charged parallel plates, they deflect towards the positively charged plate. Therefore, he concluded that cathode rays are negatively charged particles. Okay, and he also found in the cathode experiment, he also found that the particles of cathode rays have a constant charge by mass ratio, and the mass of particle of cathode rays was found to be about 1 by 1840 times of the mass of hydrogen atom. And these subatomic particles therefore were negatively charged and extremely small and light, and they were called corpuscles and later electrons. So electron was discovered by J.J. Thompson, and the name of the experiment was cathode ray discharge tube experiment. Okay, and you have to remember that electrons are negatively charged particle. Okay, electron is the negatively charged particle and electron is the lightest particle, smallest and lightest particle, subatomic particle present in an atom. Next, discovery of nucleus. Next, discovery of nucleus of an atom. Discovery of nucleus of an atom. The name of the experiment is gold foil scattering experiment. Rutherford scientist, Rutherford's gold foil alpha particle scattering experiment. The nucleus was discovered by Rutherford. Who discovered nucleus? Answer is Rutherford in 1911 through the gold foil. The name of the experiment is gold foil scattering experiment. Okay, so in this experiment, an ultra thin sheet of gold foil was bombarded with a fine beam of positively charged alpha particles. That is, scientist Rutherford bombarded a very thin, ultra thin sheet of gold foil with alpha particles, positively charged alpha particles, in an evacuated chamber. and he observed that most of the alpha particles passed undeflected through the foil, and a few of them were deflected at very small angles, and while a still smaller number, about 1 in 20,000, completely rebounded. Okay, so based on this observation, he conclude that conclusion of Rutherford gold foil experiment. Most of alpha particle passed straight through the gold foil, and indicating that most of the space in an atom is empty. Okay, you can see from this figure 4.6. Most of the alpha particles passed in a straight line, and very few, 1 in 20,000, deflect by 180 degree. Okay, so some of alpha particles are deflected at small angle to their path, indicating that a small positively charged body is present at the center of the atom, and a few alpha particles rebounded, indicating that centrally located body, which was termed the nucleus, is the dense and hard. Okay, so this the center of an atom, which is known as nucleus, was discovered by Rutherford using Rutherford alpha particles experiment. Okay, next discovery of proton using Anode Ray experiment. The name of the experiment is Anode Ray experiment in discharge tube. Same experiment. First, scientist E. Goldstein had experimented with the discharge tube and demonstrated that existence of anode rays. Okay, existence of anode ray, and he believed that anode rays consisted of positively charged particles, but he could not conclusively prove this. And later scientist Rutherford discovered the presence of, or scientist Rutherford discovered proton. Okay, so contribution of discovery of proton is attributed to Rutherford because he finally discovered this particle, positively charged particles. Proton is a positively charged particle which is present at the nucleus of an atom. Okay. And next, discovery of neutron, subatomic particle neutron. Okay, British scientist James Chadwick bombarded beryllium plate with alpha particles. Okay, and he proved that existence of neutron particles in an atom. Okay, so scientist James Chadwick carried out this experiment. He bombarded beryllium plate with alpha particle. Okay, and demonstrated that rays emerging from the beryllium were composed of particles with no charge, that is neutral, electrically neutral, but with a mass similar to that of proton, and this particle was called neutron. So neutron was discovered by James Chadwick. Okay, and the name of the experiment, bombardment of beryllium plate with alpha particle. This was the experiment of James Chadwick. And neutron particle is an electrically neutral particle present at the center of nucleus. Okay, now see here, the charge of different subatomic particle charge and their symbol also given. Electron is E minus, proton is P plus, neutron is N0, because neutron is electrically neutral. Charge in coulomb is also given. Mass of electron, mass of proton, mass of neutron is also given. Mass of electron is much less than mass of proton and neutron, and mass of proton and neutron is almost similar. The mass of proton is 1.6 into 10 to the minus 24, grams, and mass of neutron is 1.6 into 10 to the power minus 24, same almost, but mass of electron is 9.1 into 10 to the power minus 28. Okay, so in an atom, three types of subatomic particles are present: proton, neutron, and electrons. Now see atomic models. Atomic models, that how these subatomic particles are present in an atom. Okay, different scientists gave different atomic models. So first Thompson's atomic model, J.J. Thompson's atomic model. In 1903, after the discovery of electron, J.J. Thompson proposed the palm pudding atomic model. Palm pudding. This is the palm pudding atomic model of J.J. Thompson. Okay, and he mentioned that atom consists of positively charged ball or sphere in which negatively charged particles, that is electrons, are embedded, and the total negative charge of the atom balances total positive charge. And he compared his model with a palm pudding or a watermelon, and he compared the palms embedded in the pudding or the seeds embedded in the watermelon of watermelon to the electrons. Okay, and J.J. Thompson in J.J. Thompson palm pudding model, the pudding or the red part of watermelon itself was the positive sphere. He taken the pudding as positively charged sphere. Okay, but J.J. Thompson atomic model, however, failed to explain the observation of Rutherford alpha particle experiment. That's why the J.J. Thompson watermelon model or palm pudding model was not accepted. Okay. Next, Rutherford atomic model based on alpha particle scattering experiment. Rutherford proposed nuclear model of atom based on his conclusion from the alpha particle scattering experiment. And in Rutherford atomic model, the main feature are most of the space in an atom is empty, and the positive charge of an atom uh, the positive charge of the atom is concentrated in a very small volume at its center, and this is known as nucleus. Okay, and Rutherford called it the nucleus of the atom. So nucleus is the center of an atom where the positively charged particles are present, that is protons are present, and almost the entire mass of the atom is also concentrated in its dense nucleus. And next point of Rutherford atomic model, the positively charged nucleus is surrounded by negatively charged electrons, and the electrons revolve around it in circular orbit at very high speed, and the force of attraction between the oppositely charged particles, that is electron and proton, hold them together. Okay, so in Rutherford atomic model, the positively charged particles are present at the nucleus, and the electrons are revolving around the nucleus in different circular orbit. And this can be compared with the solar system, where the planets revolve around the sun in their orbit. Hence, this model also called planetary model. Okay, planetary model of Rutherford. And next point of Rutherford atomic model is an atom is electrically neutral. You know that. This is because total number of negative charge of electron is equal to total number of positive charge of the nucleus. That is, in an atom, total number of electrons and total number of protons are equal, always equal. Rutherford atomic model, however, could not explain the stability. So this is a drawback of Rutherford atomic model. Rutherford atomic model could not explain the stability of atom. According to the accepted theory of the time, if electron moved around the nucleus as described by Rutherford, they would very quickly start losing their energy, set into a spiral motion, and ultimately fall into the nucleus. And if this happened, the atom would then collapses within very short time, within 10 to the minus 8 seconds. So Rutherford atomic model could not explain the stability of an atom. And later scientist Niels Bohr gave atomic model. According to Niels Bohr proposed a modified version of Rutherford atomic model to explain how the electrons could have stable orbit around the nucleus. And the main modification in this model are discussed here. You can see the main point of Niels Bohr atomic model. Electrons revolve. He told that electrons revolved around the nucleus only in fixed circular orbit, which are called shell or energy level. According to Niels Bohr, electrons can revolve around the nucleus only in few fixed circular path or circular orbit, which are called shell or energy level, and they can jump from one cell to another but cannot occupy a space between two cells. Electron, according to Niels Bohr, electron can jump from one cell to another cell but cannot occupy a space between two cells. Okay, so important point of Niels Bohr atomic model. Second point, each cell have a fixed size and energy. Okay, each cell have a fixed size and energy around the nucleus, and as the size of the cell increases, when we move from the nucleus and nucleus outwards, that is from cell 1 to cell 2 and cell 2 to cell 3, the energy of the cell also increases. Okay, and next point, an electron normally occupies an energy level called ground state. An electron normally occupies an energy level which is called its ground state, and if electron jump to higher energy level by absorbing energy that is equal to the difference between the two energy level, this a higher energy level is called excited state. Okay, so these are the points of Niels Bohr atomic model. Okay, and now see modern atomic model. Now see points of modern atomic model. Okay, the modern atomic model based on the Niels Bohr atomic model, and that's main feature of this modern atomic model are given here. You can see this is actually modified version of Niels Bohr atomic model. And according to modern atomic model, the atom is the smallest particle of matter which comprises three fundamental or subatomic particles: proton, neutron, and electrons. And most of the part of an atom is empty. Rutherford also told this point. Most of the part of an atom is empty. Okay, and the structure of an atom is classified in two parts. One is known as nucleus, another is extranuclear part, which is also called cell, different cell. Okay, and third point, in modern atomic model, the nucleus is positively charged. Nucleus is positively charged, central part of an atom, and the nucleus consists of proton and neutrons, together referred to as nucleon. And these proton and neutrons, in one word, they are known as nucleons. Okay, so nucleons are protons and neutrons which are present at the nucleus. And next point, the extranuclear part The extranuclear part comprises orbit or shell, which are imaginary part on which the electrons revolve around the nucleus. So extranuclear parts means different shell in which electrons are revolving around the nucleus. Okay, and each orbit is associated with a fixed amount of energy. Niels Bohr also told this point. Each orbit is associated with a fixed amount of energy. The cell nearest to the nucleus has lowest energy, as we move away from the nucleus, the energy of the cell increases. Next point, the number of electrons present in an atom is equal to the number of protons present in the atom. The number of electrons present in an atom is equal to number of protons present in that atom. That's why atom is electrically neutral, because total number of proton and electron is equal in an atom. And next point, the number of proton in an atom helps in the identification of the element of an element. This is because each element has a unique number of protons. Okay, each element has a unique number of protons, and atoms of different elements have different number of protons, and the number of protons determine the property of an element. Remember this point, number of proton present in the nucleus of an atom determine the properties of an element. And next point, an atom of an element is represented by its atomic number and mass number. Next I will tell what is atomic number, what is mass number. And gain or loss of electron result in the formation of ions. Okay, when an element loses electron, then you will get cation, and if an element accept electron, you will get anions. Okay, so cations have fewer electron than protons in their atoms, while anions have more electrons than protons in their atoms. Okay, so next day I will discuss about the atomic number, mass number. Thank you, students. So today I have discussed about what is atom and defined subatomic particles and their discovery, and which scientists discovered this subatomic particle, and you have to remember which name of the experiment also. Okay, properties of proton, neutron, electrons, and define atomic models. Okay, thank you, students.